So everyone's talking about the data center power crunch, but not a lot of people are talking about the solution, data center flexibility. Let's talk about it. We got to understand how utilities perceived the load from a data center, the electrical or power load. Data center load was pretty predictable. You knew that people logged on to internet services like Instagram, Google, social media, YouTube when they wake up, during work. So the load profile was pretty rigid. Even though the data center was spec'd for 100 megawatts, it would probably only use maybe even 50 to 70 megawatts. The utility would have 100 megawatts ready for this data center 24/7 because they were designed for the peaks, the peak amount of energy, not for the actual amount of energy the data center uses. We actually produce enough power here in the United States, but we don't know when this power needs to become available. A few times out of the year during the hottest days, the grid is congested, everyone has their AC on. So there's this new concept called flexibility. We were talking about demand response programs in the past. Think of that as a similar initiative, but now we're going to talk about it in the context of data centers. As we know, artificial intelligence, AI, uses GPUs inside data centers. The load is not rigid, it's not predictable, it's quite volatile, quite spiky. That could depend on if your data center is a training data center, meaning it's training AI models like large language models, or it's an inference data center, meaning it's crunching how people are using those AI models, like when you log on to ChatGPT. So the load is quite volatile. There are ways to alleviate stress from the grid. Remember how I mentioned those a few times a year when everyone's using the AC and the grid is congested? So now we can flex the actual load from these data centers. And this is a new initiative where we can alleviate stress from the grid. There are three main ways of doing so. It's called power flex, cooling, and IT. Power, think of different types of power generation that's on site, whether you're going to solar, whether going to natural gas or diesel generators. That's one way of flexing power. Cooling, think of tuning HVAC systems, changing fan speed, temperature set points, etc. IT, think of turning off GPUs, changing clock speeds. Now, there's many different ways of going about this. This is quite complex to accomplish. Now, the utility, because they perceive the load as volatile, it's more important than ever that data centers can become slightly flexible. Now, it matters what type of data center you have, because not every data center can flex their power, cooling, and IT. So just to summarize, before, the utilities perceived data center load as pretty rigid, as pretty predictable. They designed and maintained power for the peaks, but the data centers would actually use less than the peaks. Now, the utilities perceive data centers as extremely volatile and spiky, and due to certain congestion and the rapid rise of data centers, they are looking to see if data centers can be flexible. But figuring out when to do this in a mission critical data center is difficult, and there's new companies working on this type of technology. Now, this is a figurative but good example of power flexibility. It could be shutting off a panel or switching power sources. This is an example of cooling flexibility. It could be turning on or off or tuning cooling systems. This is an example of IT flexibility, shutting off server equipment. Now, in a live mission critical data center, we wouldn't be doing this by hand. We would have to be able to schedule and go through proper change management. But figuring all this out at scale is a very tough problem. Number one, safety. If you make changes to cooling equipment, GPUs, or power, there could be some issues. You could have a breaker panel go out, a cooling system go down. And as soon as that happens, GPUs will turn off, customers will be unhappy, and you'll use your reputation and even contracts. That's why it's really important that you go through the proper systems of operations and you're able to understand when to make the change. Number two is predictability. As I mentioned, it's very difficult to know when to make a change, how to make the change, and what order of operations to do so. If you take down cooling at the wrong time, or turn off GPUs or ramp something up, it can have adverse effects inside the data center. This is where new technologies like AI for controlling data centers is coming into play. And number three, The challenge of service level agreements. Your agreement with the end customer. Data centers traditionally had a 99.99% uptime with their customers, meaning a promise to keep them up and running 24/7. So traditionally speaking, you couldn't flex IT or turn off GPUs. Now there's newer types of service level agreements or SLAs that customers are signing with data centers called Power Flex service level agreements. This is an agreement between the end user and the data center. The end user is saying, hey, I would rather take a lower price and I don't need 99.9% uptime. We'll give you a lower price tier product, but we can't promise that it'll always be available. But if that meets your requirements, then we can do a power service level agreement. So the concept of data center flexibility is not new. Companies like Google and Meta have been really innovating in the space, as well as utilities have been running demand response and energy efficiency programs. But this is where our company FLUIX comes in. We're training an AI model to flex cooling for data centers. We're already working with data centers in the United States and LATAM, maintaining service level agreements, operational safety, and even saving energy. If you're interested to learn more about FLUIX's data center AI Autopilot, go to FLUIX.ai and reach out. If you're a data center operator, just know that there are different approaches to data center flexibility, from solutions across the BMS and SCADA level to DSIM, virtualization, and even orchestration. But there are innovative companies posting case studies with utilities and other data center partners. This should help you pinpoint what's the best solution for your facility. Anyway, if this content was helpful, give us a like and consider subscribing. The purpose of this channel is to demystify data centers, and we'll be coming out with more videos talking about AI, energy, and infrastructure. I'll see you in the next one.